In this lesson, we will be learning about multiplying polynomials using something called the FOIL method. Okay, another method is going to be the box method, and then also the distributive property. Okay, so these are three ways that we can multiply polynomials. So the first way is called the FOIL method. So we can only use this when we're multiplying two binomials. Okay, so the example problem down here is two binomials. Remember, a binomial is two terms. Okay, so the word FOIL stands for first, outer, inner, last. Okay, so it's talking about the terms that we're going to multiply. Okay, so if I multiply the first two terms, here I have y times y, which is y squared. Okay, outer, the two outer terms, y times 7, so plus 7y. Inner, the two inner terms, 3 times y, and the two last terms, 3 times 7. Okay, and then I'm going to combine the terms that are the same. I see that in the middle I have 7y and 3y, which is going to be 10y. And then the other terms I'm going to bring down. So y squared plus 10y plus 21. Okay, let's try one more. So first, y times y, y squared. Outer, y times 7, 7y. Inner, 3 times y, 3y. And 3 times 7, 21. Okay, so this is actually the same one. Add 7y and 3y to get 10y, and bring down 21. And y squared. Okay, notice that it's in order, the highest term. Okay, so it's y squared, y, and then nothing. So you want to have the largest term first in order. Okay, so pause the video for a moment and try this one on your own. Okay, so with this one you should have done y times y, which is y squared, outer plus 2y, inner plus 4y, and last plus 8. Okay, then I see I can combine the y's. So 4 plus 2 is 6y. Bring down plus 8 and y squared. Okay, so that's your answer in red. Okay, so the second method that we can use is the distributive property. Okay, so in this term, what we can do is break apart the first term. Okay, so this is the original problem right up here. So what I've done is I've taken this first 2 and multiplied it with 5x and with 8 right here. Okay, then the second term, the 3, which is right here, is being multiplied with the 5x and the 8 here. Okay? So basically what I get then is I have my 2x times 5x, which is going to give me 10x squared. And then 2x times 8 is 16x. Okay? So this first 2 that was out here, I multiplied with both. Then I add the 3, my second term, with both. So 3 times 5 is 15x. And 3 times 8 is 24. Okay, now I'm going to go ahead and combine together the x's. So now here I have 31x. That's the only one I can combine. 10x squared plus 31x plus 24 is your answer. Okay, so again, using distributive property, if I want to rewrite this, I'm going to take the first term and multiply it by the whole second. So 2a times 2a plus 4b. Okay, then I'm going to take the second minus 3b and multiply it by the whole second. Okay, so this is called distributive property because I'm distributing each of the terms in the first binomial to the terms in the second. Okay, so 2a times 2a is 4a squared plus 8ab minus 6ab and minus 12b squared. Okay, remember because I have b1, b1, so I have b2. Okay, so again, the terms in the center, I can combine. I have positive 8 minus 6, so I have 2ab. Okay, and then the first term, 4a squared plus 2ab minus 12b squared. Okay, so this is going to be as much as you can simplify. Okay, so let's pause the video for a moment and try these on your own, okay? I also forgot to say that the reason that we use distributive property is, notice that the one below is a binomial, it's 2 and 2, but if we had something longer, like a binomial times a trinomial, okay, then we'd have to use distributive property, or the next one that I'm going to show you, okay? All right, so let's go ahead and do this one. So 7p times the second term, 3p minus 4, okay, and then negative 2 times the second term, 3p minus 4. Okay, now we can distribute 21p squared minus 28p minus 6p plus 8. Okay, I can combine the p's in the center. I have minus 28 minus 6, so that gives me minus 34p. Bring down the 8 and the 21p squared. Okay, so final answer, 21p squared minus 34p plus 8. Okay, so here was kind of what I was trying to show you guys in the last one, where I have a binomial times a trinomial. Okay, this is p squared. So I take my first term, 2p, and I multiply it by the second, p squared minus 3p plus 4. Okay, take the second term in the first, 1, positive 1, so it's plus, times the second, p squared minus 3p plus 4. Okay, now let's distribute. 2, this is 1p, so 2 times 1 is 2. p1 and p2 is p3 minus 6p squared plus 8p. Okay, next one, plus p squared minus 3p plus 4. Sorry, that's a plus. Okay, let's combine what we can. I see that I just have 2p to the third. I only have one of them. Okay. Then the next one is I have minus 6p squared and plus p squared. So that gives me minus 5p squared. And next I have 8p minus 3p, so I have 5p, and then just the plus 4. Okay, so everything is simplified, starting with the largest degree first, 2p to the third minus 5p squared plus 5p plus 4. Okay, so let's pause the video. I want you guys to try this one on your own. Okay, so here we would take 2x from the first term and multiply it by the second, x squared minus 5x plus 4. Okay, take the second term. Because it's negative 5, it becomes minus 5 times the second, x squared minus 5x plus 4. And now let's distribute. Okay, so I have 2x to the third minus 10x squared plus 8x. Okay, minus 5x squared plus 25x minus 20. And combine. Okay, there's only 1 to the degree of the third power. I have negative 10x squared and negative 5x squared, so I have negative 15x squared. Cross those off. 8x and 25x gives me 33x, and then I just have minus 20 left. Okay, so with the degree starting first, it would be 2x to the third minus 15x squared plus 33x minus 20. Okay, and then the last method to multiply is that we can use something called the box method. Okay, so here are the 3 steps. Okay, so you would start off with something that looks like this problem here. Okay, so the x plus 2 is right here, x and 2. And then the x squared plus 3x minus 1 is going across the top. So in the boxes here, I'm going to multiply x times x squared to give me x to the third. Here, x times 3x gives me 3x squared. And x times negative 1 is negative 1x. Okay, in the second row, 2 times x squared gives me 2x squared. Okay, here 2 times 3x is 6x. And 2 times negative 1 is negative 2. Okay, so that's what you can see down in the next row. Basically, this times this is this. Okay, 2 times x squared is here. Okay, so that's how it works. So now, my answer is all of the parts inside. Okay, so all of these are my answer, and I need to simplify them. So I have 1x to the third. So down here we see we have x to the third. Then I'm going to combine my 2x's, or I'm sorry, my x squareds. So I have 5x squared. Okay, then the x's, so plus 5x. And then the minus 2 is on its own. Okay, so this is another method that you can use to multiply polynomials. Okay, so let's try this one using the box method, and we'll go ahead and create it ourselves. Okay, so there's no right or wrong way. I like to put the longer one across the top. So we have x squared, then minus 5x, oops, and then plus 4. Okay, and then going along the side here we have 2x and minus 5. Okay, so now I'm going to multiply here 2x times x squared would give me 2x to the third. 2x times negative 5x, negative 10x squared. 2x times 4, 8x. Okay, next row, negative 5 times x squared, negative 5x squared. Negative 5 is negative 5x, is negative 25x. And negative 5 times 4 is negative 20. Okay, so now the last step is to combine everything together. Okay, so x to the third, I only have 1. 2x to the third. My x squares, I have negative 5 and negative 10. So negative 15x squared. Okay, next is the x's. Negative 25 and positive 8 is going to give me negative 17x. And then the last term on its own is negative 20. Okay, again, the degrees are starting with the largest degree of x to the third and going down. Everything is also simplified. Okay, so again, just the 3 ways to multiply polynomials is the FOIL method, okay, where you can only use this with 2 binomials. You can also use distributive property, and then this method right here, the box method.